Today, we are going to learn how to set up the Aerodynamics Design Challenge. We'll be putting together the setup in Ohio State's Aerospace Design Laboratory, but don't worry, we won't be using anything but everyday objects that you can find around your home. The Design Lab isn't always the cleanest room on campus, but in here you'll find the latest aerospace technologies being worked on by students and faculty, from the latest developments in unmanned aircraft to high-powered rockets over 7 feet tall. This lab is also equipped with a flight simulator and a wind tunnel. Research-grade measurement tools used in the wind tunnel can cost thousands of dollars, but you can build a simple test stand for your design challenge for under $10. Here is everything you will need to perform this design challenge: a box fan, 2 scales, and the test stand that we'll be building next. For your test stand, you will need a small piece of wood. I used a square piece of balsa, but any type will work, and you could even use circular dowels. We will use this wood in order to construct an L shape. In order to do this, first cut the wood into 2 pieces. Make sure that both legs of your L are the same length. I'll explain why this is important later. Glue the 2 pieces together to form the L. After it dries, drill a small hole through the center of the corner. The stand will pivot on this axis. Next, take 2 small squares of wood which will serve as supports for the stand as shown here. Use a nail or something similar to connect the 2 sides together with the L sandwiched in between. The L should be able to pivot freely. Here's what my completed test stand looked like. Now let's briefly discuss how it works. The scale sits under the mechanism as shown. Then lift and drag forces are applied to the test object. The scales measure the vertical force applied here and here. Newton's second law applied to this setup tells us that force is equal to mass times acceleration. Since the test stand is fixed and not moving, the right-hand side is 0. This tells us that all of our forces must add up to 0. Looking just at the vertical forces on the setup, we add them up. Then we can say that lift must equal the sum of the 2 readings on the scales. The negative sign means that the negative readings represent positive lift. We can also apply Newton's second law to rotation. This means that the torque must also add to 0. Only drag and the rear scale force could cause the setup to rotate on its axis, so their torques must be equal to each other. Here's why having the same length arms was important. Now the length cancels out, and drag is simply the reading on the back scale. Remember that streamlining, or creating smooth contours without sharp turns, is key to drag reduction. Redirecting air to flow downward is key to lift. Have fun with the Aerodynamics Challenge.